Let's give Bryan a big round of applause. Hello, SecKC. You guys ready to have some fun?
Yeah!
All right, we got the peanut gallery is ready to have fun. How about everybody else? Nobody? Yeah? Okay, we'll give you that. Really? You don't want to try again?
Yeah.
Okay, well, fine. All right, so, yeah, there we go. All right, so we're going to talk about a topic that most of you probably have heard about, and you might go, well, what the fuck is that? And actually, Corey gave us a talk about some of this a while ago.
Who the fuck is that?
And he gave us a basic intro to, you know, kind of looking at how an application runs on your computer and how to look at behind the scenes and kind of see what's happening. Well, some of us professionally take a look at the applications that developers write, and we want to extract sensitive information out of them, find out what's going on, make sure you're not doing anything weird. I've given a couple of talks on this at a higher level, but what we're talking about today is going into assembly level reverse engineering. And the goal here is not to teach you all to be reverse engineers. What we're trying to do is get you to the next step, right? I'm pretty sure there are probably like, how many of you have heard of reverse engineering?
Not me.
How many of you have heard of a debugger? How many of you know what a debugger does?
The dishes.
Okay, good try.
I tried.
Wait, does it though?
So we're going to get to that. So in the spirit of getting the audience involved, we have Trent over here. Trent has Corey's sack. Okay? And if you can successfully answer a question that I pose to the crowd, you get to reach into Corey's sack and take anything out of it that you want.
It's Friday night all over again.
Is it bad? Wait, where is it? 'Cause
I need an adult.
All right. Here, let's turn on this microphone, and then Trent will give you another job here.
Hey, watch out for the speakers.
Here, yeah, don't point at the speaker. Need that part too. All right. Okay, so we want to find out, is there anybody in the crowd who can describe what a debugger does? Anybody? Anybody want to try?
It's used for when you're trying to look busy.
When you're trying to look busy. It's a good one. Okay, anybody else?
It pauses the program and or processor so you can take a look at it.
Hey, we have a winner. I think that's good enough. Okay, repeat it.
It pauses the program and or processor so you can take a look at it and fiddle with it.
All right, give that man a reach into Corey's sack.
I'm over here.
Is he fiddling with Corey's sack?
Throw it back! It's a knife! Yes!
Okay, so that is a correct answer, but not a complete answer. So it does pause the application. That's one of the things it can do, and allows you to see what's happening. One of the other things it can do is allow you to step through instructions one at a time. Right? You're looking at what it's doing as it's happening, and it allows you to see the memory. Probably the more fun thing that it allows you to do is actually modify the execution of the application as it's running, okay? So that's really fun for when you're in the midst of it and you're kind of looking at what's happening. We're going to take a look at this in a little bit. You can see what happens when, oh, that instruction's going to do that and it wants to go there, but what if I do this and make it do something else, right? What can we make it do? So let's get into it. You guys want to see what a debugger looks like?
Yes!
All right. Woo! Yay! Round of applause for Bill. He answered a question.
Hey,
All right.
you have to put that shirt on right now.
All right, so earlier, you may have seen my Twitter post earlier where I announced I was going to do no slides, but Aaron, a friend of ours, responded and sent me a picture that I couldn't resist, so I'm going to have one slide for tonight. So this is it. Welcome to SecKC.
Secure it.
Isn't that awesome? I mean, that's the best slide you could possibly put up. So there we go. That's our slide for tonight. You can prove to your boss that you were here and you watched the talk and you learned something. You learned secure it at SecKC. And I think that's Bill's fingerprint, so take a picture real quick before it goes away. All right, let's get going. First thing is you may notice that this is a Windows machine running on a Mac, because you can do debugging stuff in a Mac, but for our purposes, I wanted to use some open source tools. Well, free tools. They're not really open source, but free tools so everybody can kind of get an idea of how this works, and you can go and try it when you get home. Next thing I want to set the stage for is that the example that we're using in this talk is from the FLARE-ON competition. It's an annual competition they do every year. They have a whole bunch of reverse engineering challenges, and I just did it for fun, had a couple of hours, and one of these came out, and I was like, hey, let's do a follow-up talk. We've been talking about doing this follow-up talk for a while, and I thought this was a perfect example to walk us through kind of the techniques that we're going to use to learn to take that next step. Remember, I mentioned earlier, we are not here to learn the solution to this challenge. We're here to learn the techniques that I would use as a professional when I'm taking a look at an application or given an application and said, okay, go, right? You need to know how to start. And Corey showed you, okay, how do you load it up into debugger? What are sort of the things you want to kind of look at? But when you get into a more complex application, what are the things we're going to start doing? And that's what we're going into here. And we're going to actually solve this challenge tonight, all right? So if you get bored, shout at me. If I see you dozing off, I'm going to shout at you or ask questions. Does everybody sound happy with that?
Your password sucks!
Yeah, these VMs. These VMs are free, by the way. If you go on to Microsoft's website, if you're a person who does what I do, we need to set up clean VMs all the time. And we don't want to pay for a license for every one of those machines, or even keep, all that crap around, because we've got to test all the different kinds. So you go onto Microsoft's website on Edge or something like that, and you download the thing and you put it on there and it runs for 90 days. No cost at all. So I recommend you do that if you're doing this kind of stuff. Is what? You got something to say, man?
Give him the mic, make him say it.
All right, we'll keep going. Okay, so let's get started. The IgniteMe executable is one of the things that the FLARE-ON challenge gave you. So when I first get started looking at one of these applications, trying to figure out what the heck to do with it, I just like to run it and use it and get an idea for how it behaves. The reason for that is because it will affect the way that you go about looking into what it's doing, right? If you run the application and it does nothing on the screen, well, then you've got some more interesting things to do. Are you going to dig through processes? Are you going to, look for network connections? Is it going to prompt you for information, or is it going to listen for a network connection? All those things are things that you want to know when you're starting to reverse these applications. So fortunately for us, in this case, you run the application and it prompts you for some information, right? And right away we can try just 1, 2, 3, 4, 5, 6, 7, 8. I like to use 8 A's because I know what the hex code for that is. And run it, see what happens. Oh, it disappeared, right? So next thing is we'll run it from the desktop. All right, we'll give you the flag. We'll do it again. 1, 2, 3, 4. 1, 2, 3, 4. No, failed. Okay. So now we have some idea of what this thing does. It prompts you for a flag and it stops. Really simple, right? So now what do? Let's close it and open up our debugger and see what happens. Fortunately for me, I've already done this, so it's right here in my drop-down list. Do you want me to go to the desktop?
Yeah.
Nobody? Yeah?
Yes.
Yes or no? Hands up for yes.
What was the question?
All right, we'll go to the desktop. We're gonna hit the open button and we're gonna scroll down to it and open up this application. Yay, it worked!
What did you do?
Okay, so we ran the application. Woo! We got it in the debugger. Okay, so this is important, okay? Because some applications will crash at this point because they've detected that you have a debugger attached to them. That is a much, much different talk. We're not there yet, okay? We're still getting started.
Is that next month?
No.
Is that the next slide?
Okay, so next thing is that I'm using the Immunity debugger here. It's free, you can download and install it. This is not my endorsement of this product. There are other debuggers. You might have heard of IDA Pro, you've heard of Hopper, you've heard of BitNinja, or whatever the Ninja one, the new ones are. They have a lot of other variously costed, or priced. Costed isn't a word, is it? It's priced, variously priced licenses.
At SecKC, it's a word.
Okay, we're going to call it costed from now on. But this is just one of the tools that you can use. This talk is not a, here's a tool you need to use. This is a way to do it. Remember, we're focusing more on the technique as far as understanding how the application works, the places you need to go, right? So one of the cool features that Immunity actually provides is that I've loaded up the application in the debugger. The first thing that I like to do is click this little button that says graph the application, okay? This is actually pretty cool because immediately I get to see all the instructions that this application runs from what's called the entry point. That's a keyword that you want to remember. Any application has an entry point, that's where it starts its execution, and then as a reverse engineer, you got to kind of figure out where that's at in a lot of cases. And in some cases, as I mentioned, it might be a network connection that it's listening. That's the point where it's always reestablishing what it's doing. In this case, we have a really basic application, so it starts pretty much at the beginning when the first main function is called. But if you scroll through here, you can see Immunity is actually really helpful. It tells us, hey, here's this ASCII value, give me the flag, right? And we saw that when we ran the application. Remember that?
Yes.
What happened, who can answer this, what happened when we entered our data?
Evaluated it. It didn't move to the next step.
What did it do? Not what didn't it do, what did it do? It waited. After we typed in the data, what did it do?
It failed.
It failed, right? Okay, give that man a grab into Corey's sack.
Oh man, good thing he's right here.
All right, so if we scroll down a little bit, we see, okay, give me the flag, and then you have on one side here, we have this ASCII value. Not too hot, are we? Try again, please. This was the branch that we took, right? On the other side, if you look right over to the side, right to the other side, the other option is it can tell you good job, right? I think that's where we want to go, right? Do you guys agree? You want to go to the failure or the good job side? Do you think that's where it's going to get us to the end of this challenge, is if we get it to pop good job?
Look, it's just the end of the talk.
All right, we'll speed this up. I'm gonna need a fan after that. All right, so let's take a look. All right, we're gonna give you a first look at the debugger. We're gonna relaunch this application. And actually, let's go back real quick. I missed the part. When you're looking at these applications, we're not going to focus too much on the assembly instructions themselves on every single one. We'll talk about the important ones and we'll talk about some of the techniques later on. But in this case, I'm going to jump to a technique for you, is that when I am looking for a solution to doing one of these things, I like to work from the end as where I can find out where it's trying to make a decision and work my way back, right? So in this case, we have this jump short that either jumps you down to you failed, or it passes on to this other one where you did a good job, right? So just before that, though, we see this test instruction that happens. So what this is doing a bitwise AND comparison. I'm not going to explain exactly what that is, but it basically compares two values and determines, it sets a flag, right? And then the next value says, okay, jump if they matched, essentially is what was happening. JE is jump if equal. So what we care about in this case is, well, what happens to these values just before here that is causing it to either pass or fail, right? So that's where we want to start digging in. So if we look at this 00401050 is a memory address inside of the application. It's an offset. So we're going to go take a look at that and try to figure out what's happening. So as we open up our CPU instruction screen here, this is the entry point. So you'll see all the same calls that were shown in there. And if we keep going down, we'll see call to that one, that 401050, and then we have the test, and then we have that jump short, right? Looks exactly the same as what we just saw, right? Everybody agree?
Yes.
Awesome. Okay, so the first thing that I'm actually going to do is take a look and show you what that test function looks like. So first thing, we'll set a breakpoint right on that test call. By the way, as
Rickson.
no, Rasovax, or however you pronounce his name, said.
Anthrax.
Anthrax, there you go. We get to pause the instruction. So breakpoint is a point you set in the code. It runs down, the application will run until it hits it and then stop, right? It allows you to see what's happening. The beauty of that is that you don't have to hit this little step in button on every single instruction and follow in, you know, and Corey showed how to do this in GDB, I believe, back in the day. So we're going to execute this program, which just looks like that. It's going to prompt us for the flag. You can see we're going to 1, 2, 3, 4, 1, 2, 3, 4. The reason I use as I mentioned, is it's OX41, and I like to use 8 input bytes because that generally perfectly aligns with a byte boundary, or the memory lines here. So you've got 8 bytes. When you see it show up in memory, it'll line up perfectly. So it's just a quirk thing, and I'll change the values as we get further in. But it's just, yeah.
Sorry, so you're using that 8 A's as a flag inside the memory to go through and kind of see where the test is.
That's reaching a little bit farther, but you'll get to a point where when we look at the memory that gets put in there, we can see clearly where it gets stored. Okay. So, and we'll look at that. So I'll just use it, as basically a locator, right? And there are some more complex or sophisticated ones, like Metasploit has a pseudo-random generator that will do it to a specific byte range, and if you can copy the specific 4 bytes or 8 bytes out of the memory segment, it'll actually tell you exactly the offset rather than, you having to figure it out manually by, manipulating the stuff. So again, other tools, but for now we're going to focus on this. So we've typed in our input. We haven't hit our breakpoint bit yet. So when we hit go, I got to hit enter after I enter input. So we're going to hit go, and we're going to have to do that again because I failed. Okay, hit run, type in our input, 1, 2, 3, 4, 1, 2, 3, 4, enter. We're at our test instruction here, okay? And we can see that it tests EAX, and it jumps short. And if we step in, because this is where that function is handy, we can see that we get to the jump short, and if we execute that next function, we'll just run from here. It fails, right? Just as if we had run the application outside of the debugger, but we can see exactly what's happening in that case. So we're going to run it again, but what we're going to do instead this time is we're going to do 1, 2, 3, 4, 1, 2, 3, 4, same input, hit enter. We're at test EAX, test EAX. Now, one of the things that the debugger allows us to do in this case is modify the memory, as I mentioned. So we can test our hypothesis about whether or not this is the function we're interested in, right? Who wants to do that? All right. Any suggestions? Do we want to put in zeros here again, or 1, or 2, or
3? Maybe in
3?
Emojis.
All right, we'll put in a 3. Let's see what happens. And now we're gonna run it. Hey, we won! It said good job. But really, if you're in a CTF or in a challenge in this case, you got to the end of the execution, but they're going to ask you for a flag. Well, what did you put in there to make that happen? So what you need to know in this case is that, yeah, okay, we got this thing executed successfully, we got to the end. But we haven't gotten the sensitive data that we would put into the application. So if you went and did this, so in a case where you have an application and performs a license check, if you're able to do this, you just passed it. You got to the end, right?
Excuse me, sir.
Hey, Corey, do we have a tradition here?
We have a tradition here at SecKC. That if you do a reverse engineering talk, you gotta do a shot.
Thank you for that. Oh, that should actually make this easier. All right, let's have some more fun.
Good job.
All right, good job. Yeah. All right, so we got past that point. So, like I said, if this is license check, you just won. You got to run your, $5,000 software for free because you got past that check. But as I mentioned, that's not the end of this. We need to figure out what the application is doing to hide the data that we want to put in there, right? So we're going to go back and look at our graph, our call graph. Actually, let's restart the application so we can get back to the beginning. Our call graph here, remember, we said we just tested out the EAX. We verified that this is the point where it determines whether or not we pass or fail. So what I like to do, let's go back, start from the end, work our way back. We're going to take a look at this 401050 function. Okay, so we'll close that, take a closer look, and actually we're going to maximize this to move along easier. Okay, so we're going to look down. So we have this call here, 0040150. Okay, so everybody agreed that that's the same place. Okay, so we're going to set a breakpoint here. Now, if we wanted to, we could, run this application again. Where did it go? And we're going to type in the stuff, blah, 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 1, 2, 3, 4, 1, 2, 3, 4, run it again. Okay, it's back at our breakpoint. So, yeah, we could hit the step in button, and we could keep doing this. We could keep going and going and say, oh, look, there's a loop there. It seems to be doing the same thing over and over again. And if you look over here in the memory, you can see things changing. Like, it's taken our input values, and it's doing something with them, right? Now, if you did this, it would take you all day to figure out what the hell is going on, right? Does anybody have a suggestion for what we might do instead?
Hold down the enter key.
Good try. Okay, that's a good enough try. Give that man a reach into the sack. Here at SecKC, even really bad answers are good answers. All right, so
Stupid questions.
No dumb questions.
anybody else? Hold F4.
Try it.
All right. Who can answer, I will buy you a SecKC patch, if you can answer what F4 does? He wins. All right, so say it louder. Shout
It
out.
closes the window. It's like RTS. Read mail really fast /root.
All right, I owe you a patch. Okay, all right. Anybody else? Anybody have a guess at a better way to go about this solution?
Say, debug.
Okay, a breakpoint after it. We already have a breakpoint right after it, so
Jump out of the subroutine.
anybody else?
Well, okay, so it's feeding that part of memory from somewhere. Figure out where it's pulling that information from and then read it.
Close. All right, so I don't know if he wants me to say his name. So Asimodian, we'll give him a reach into the sack if he wants it. Trent, give him a sack reach.
Yeah.
All right, so
Card right there.
all right, okay. The answer that I'm going to use is that we will do what's called a run trace. Okay, so we have our breakpoint. Let's start it back over. Run the application. Type in our input 1 2 3 4 1 2 3 4, and we can open up this little window. And if we hit this button, it's going to run over all the instructions until it hits the next breakpoint and dump them all to the screen for you, right? It's really, really useful. But one of the even more useful things is that we can hit this little log to file button. Okay, so we'll just open up a file on the desktop, tell it to log to the file. We're going to hit trace over. If you look down here, you'll see that it's tracing, and eventually it'll hit paused, right? Finished up. So we can click back over to the run trace, and we can see all the instructions that are executed on that sequence of events, on the input that I put in, right? So we can figure out what's going to happen with those. Because remember, we're going back to technique. We're not really that concerned about what exactly is happening in this application. What's more useful is for you to go away and say, I want to do a different challenge, and I can use these same steps to try to solve the problem, right? So that's what we're after here. If we go to the desktop now, we will see that there's this rtrace file. It's almost 9K. So we'll go back over here. We will tell it to close the log file. And we will open up our network to our share here. That's not the button I meant to hit. The demo failed. We're going to go to the desktop and copy this over. All right. So that gets us back over to our host machine, because now we've run the application through the debugger. We've gotten to take a look at what's happening. We've dumped the assembly information that's there, and now we want to dig into it, analysis, right? What? If you're going to say something, you got to say it out loud.
I said, does he really have zero cool?
Yes.
Yes.
There a crash override setting?
No names.
That's another machine. All right, so I'm going to have to set this down to type now. Oh, and I mentioned to Joel, we've had a lot of people do this, and you can turn a microphone sideways, and it still works.
You need that thing that Gene has.
Can you repeat the last place? I'm not getting it. Who's Joel?
Like, you don't have to do this and like talk over your screen. You can just turn it
How do you turn a
sideways.
sphere sideways?
How do you turn a sphere sideways? All right. Okay, so we're going to go into projects, Flare. This was IgniteMe. So we have our file here, the rtrace file, and we're going to take a look at what the instructions look like. Yeah.
Oh.
Yes.
Is there another text editor you should be using right here?
I am going to show you the vast superiority of the Vim text editor during this presentation.
What about Nero?
Can somebody cut the
If you take anything away from this talk, it is the fact that Vim is the single best text editor that's ever been made.
All right, hey,
If you use Vim, you're banning him right now.
all right, continue.
Hey, isn't Vim Rock 13 for piano?
JKLM. These are the important questions.
Seriously, check it.
SecKC.
All right, now we're having fun. Okay, so now that I've had a shot of alcohol, we'll see if I can figure out what the hell these things mean.
Hey, did you turn that sideways?
Okay, so
It works that way? Yeah, apparently.
So the next step, when you're starting to take a look at your application and trying to figure out what the hell's going on, you're going to look through these. And honestly, what I do when I'm dead serious about this, when I have an application that I'm trying to tear apart, I will literally go through these one by one and type what exactly it's doing over here on the line next to the instructions, okay? I'll say, hey, in this case, it's allocating 0C, that's hex, by the way, amount of memory. And it's pushing some information. These are arguments that are going to be called for that function call, right? We're not really here to talk about exactly what those are doing. What we're worried about is the technique of going through, you're going to pull up your search engine, you're going to look at each of these and see, oh, there's an add call. What the hell does that mean, right? You're a beginner, you watched Corey's talk, you understood that something's happening, but the computer's doing something, right? It's making stuff happen, it's putting stuff in memory, it's moving it around. You're going to literally look up each one of these calls and write down what it does next to the command, or next to that command. And that way, as you're digging through, you can see kind of what's happening, right? The next step is, once I have kind of an idea of what's happening, the prologue, you'll get an idea for what that looks like. But I'll start looking at these memory addresses over here. The main thing that I'm looking for is repetition. Okay, we saw as we were stepping through, anybody, can you tell me what was the thing that I mentioned as we were stepping through that was interesting?
It was looping.
Yes. Give him a reach on the sack.
Who said that?
All right. So looping, and essentially what that looks like in assembly is that you're going to see the same memory addresses called over and over again. So as we come down here, you'll see that we have gaps because there are going to be calls and jumps and things like that are going to happen. So we have this from 77 to 82, which looks normal, and it keeps going up, and we go look down, and oh look, there's an 82 again, right? So what I'll do for my own sake is just, hey, let's break that up. That looks like it was a repetition. So we'll keep going down and look again. Oh, there's another 82. Does it look the same as the last one, right? There's a 7F that happens just before it, and then it jumps down to 82, 86, 88. 7F, 82, 86, 88. Okay, so I think that's probably the loop that's happening. We'll keep going through. 82, there's another 82, there's another 82. And, you know, after a while you see that they're happening and you just look for the last one. Okay, 82. And then we have a 7F. We look at the functions that, or the calls that are made, or the instructions, rather. Let's be technical here, right? This is a technical talk. We need to be accurate.
We said we're going to have technical talk.
We need to be technically accurate so that the guys on YouTube that are going to watch this later can't come back and tear it apart because I said call instead of instruction.
They'll do it anyway.
Yeah, they will.
And I'm going to comment about the nano thing. Don't you worry.
Oh, okay, so we've got 7C, 7F. We've got over here, keep going down, we don't see 7C, 7F, right? So we have 82, 86. I'm going to kind of take a look at, so 82, 86, 88 is not existing down here. So that looks like that's the end of our loop. So something happens, and then something else happens. So to make this less painful, I'm going to jump over to the marked up version of that I've already gone through for this, right? So let's save that off. But we're going to go into archive, and there's one in here somewhere. R-trace, there we go.
What's red tube?
Okay, so, oops, we don't want to show that. Okay, so this is an equivalent trace, but with some other input that I put in earlier. But you can see that what I did was go in here and just write in the instructions for each of the steps. Allocate 12 bytes of memory. It's going to call that function with those arguments. What's happening with the loop. And then we have loop again. Copy values. We're going to go down to okay, so this is the interesting bit of loop. For each of the values that is input we can see that there's going to be data written to a local value. So here's some information for you. When you see a call into SS and then you have a base pointer -8, the -8 tells you that it's going to some local variable. Okay? If you see a +8 or a +4 or any offset really, and in a lot of cases for arguments there are going to be 4. That means that it's an argument to the function call. And that's just a convention that's used. It's not always the case, but it is an assumption that you can make in a lot of cases. So if you see -8 or -4 or -1, like in this case, we have another variable. It's a 1-byte variable in this case instead of a longer variable that's used in that case. So we have some data that's copied in. Let's take a look at our notes here. Actually, we probably need to zoom out a little bit. Oh no, I can't figure out how to zoom out.
Alt F4.
Alt F4. There's a zoom in here somewhere. Zoom. I'll just zoom all. All right, we can zoom in, but we can't zoom out. So why don't we just, we're gonna quit it. Hey, look, and it does it automatically. Yay for screen. All right. Okay, so we'll see here that we have some data copied into a local variable. If that variable's less than 0, we're going to jump. Then you see that there is a 15 here, and that's based on the length of the argument that I put in. Okay. So you'll see that it's doing some stuff, copies 1 byte from a specific offset in the data segment. So in this case, we have this EDX plus 403078. Now that's interesting information because when you see these data offsets, that means that there's something in the data segment specifically, there's something stored in the application that it's going after, right? Or it's written it to the data segment. But in this case, we haven't seen anything written, but it's pulling something from the data segment and putting it into EAX, right? So we might be interested in looking at that. So this is 403078. We're going to go back into our VM. We're going to take a look at the CPU. And down here is our data that's dumped. 4030, what was our offset? 078. So we can scroll down, 078. Hey, look. Does anybody recognize these numbers? What do they mean? Yeah, the data segment's a little small there.
That's your input, right?
Yeah, so that's the input. So it's copying the input into a value and trying to figure out, it's doing something with it. So that's good to know. So we can switch back. Take a look, keep moving down. Copy 1 byte from our local variable. This, by the way, the OX4 is set somewhere up here. Okay, so that's not the one I'm looking for. Okay, so that node is not there. We're just going to assume that this value is set to the hex value 04. Okay, it is a static value that's set by the application when it runs. It's literally in the source code. It's going. You'll see if you step through the code. You'll see that it's set statically. So the first thing that happens is it uses that value, and then it XORs that first byte that it copies from an input against that 04. Okay? That value is then used, copied into EDX, and then we have 074 is the result. So what we know in this case is that there's some data that it's using in the application against the input that we provided, right? So it's masking it somehow. It's using an XOR. Now, who here can answer what XOR does? Anybody?
XOR's thing.
Okay.
0, 0, 1 is
Yeah,
0, 0, 1,
right.
1 is 0.
Okay, so what is an interesting property about XOR?
Chambers is false.
Wait,
XOR encryption.
okay,
When you hand it, it's 0.
that's interesting, yeah.
Twice that does it.
There you go. It's reversible. It's immediately reversible, okay? If you can, give them another reach into the sack.
No. Take it back, Trent.
If you see that one value is XORed, by the way, it does apply to encryption because XOR is used a lot in encryption, but it is not in itself encryption because it is directly reversible. If you take one value and XOR it by another value, and then XOR it again by either one of the original values, you get the same value back. Like, that is how a lot of stream ciphers work, okay? So in this case, we have data that's stored, that's XORed against your input, and then you get some other data. So, what do we do? No ideas? So the data has to be stored somewhere, right? If it's XORing this against it, it's either doing it from like this, in this case, it's a specific value, or it's stored somewhere. So what do? We keep looking through the loop. Let's go down to the next iteration and see what happens. So we have, we're going to look at the data segment elements. So that's the next tip, right? If you're going through this and you see that something's happening, you want to start looking at anything that's coming from your data segment because that indicates that there's some hard-coded value stored in the data somewhere that it might be using to manipulate the data. In this case, we have this DS403078. We've already looked at that. What is that? Anybody? Anybody remember what 78 was? Input. Give that man a grab in his sack, Corey's sack. All right, so we go down and we see 403180. This is another offset. Did anybody happen to notice what that was when we were looking at the screen before? No, so let's go look at it. 403180. By the way, we can just do this. Go to 403018.
3180.
3180? Yep. There we go. Okay, so we see mostly null values and then a 45, right? There's not really much here. So, but that tells us something. That tells us that it's using the values that are stored here for some reason, okay? So we'll keep a look at this. We'll keep it in our mind as we're digging through the disassembly. So we'll keep going through 403078. Again, it's taking our input, doing something with it. Keep going, copy local variable, subtract 1, keep going. Local variable, loop, right? It's going to keep doing this over and over and over again. It's doing something and XORing some data with the input we put in there.
It's 7:30.
Oh, do we need to stop now?
Derail the talk,
Dude, there's a ton going on.
Jump to the next slide.
All right, so next slide. It's going to do some stuff, and it's going to do some more stuff, and
Hey, does it do stuff?
it does a lot of stuff.
Okay, cool.
Okay, I'm going to look at my little piece of paper here.
Are you cheating?
I have my own slides here that you don't get to see.
Can I see?
Is that a Corey side?
Are they in Vim?
In Vim. Yeah, actually, now that you ask. Okay, so down here, this is the interesting piece. So we've done a bunch of stuff, XORed their data with the input data, right? We're speeding up now, can you tell? At the end of the loop, we see some other function that's happening, right? So we have data copied into a local variable, copy 1 byte previously from the data segment, copy from another data segment, which is 4030000. Okay, this is another data segment that we haven't looked at yet. So we're going to go do that. And if we look at our data segment down here, 430, we got to go way up to the top. We have 4300000. We see this random looking data. Okay. The next thing, we're out of time on this, so I'm going to kind of skip things a little bit. But the next thing that you would do is start assembling that next piece. We're going to jump down to that next call. Let's see, what was the address? Here, 0C7. Let's go ahead and copy that. We'll say go to expression, and we see our call here. And the very first thing that you'll notice, Immunity is helpful in this respect, is that it falls right in the middle of a loop that's happening. Okay, so there's another loop that's modifying the data that is comparing before it moves on. So we can look at this real quick. It is copying some data into a local variable, copying and checking to see these two, check to see if the value is not longer than 27 in hex, which actually turns out to be 39, right? So it loops through there, does some more comparisons, checks the values, a compare, and then it does another XOR, right? So digging through all these, you end up seeing that we had an original loop that happened to our input, it did some XORing, put the data into our data segment, and then you have another loop at the end that goes through and loops again, and it's actually comparing the data that was modified in the original loop against the data that's stored in our in the data segment here. So if you count 1, 2, 3, 4, 5, 6, 7, 8 times 5, you end up with 40, right? And you see that that last value is a null, so we actually have 39 values that are used exactly to do this comparison. And that gives us a pretty good hint at what's happening here. What time are we scheduled for?
7:45?
7:45?
Yeah.
Okay, and we're at 7:30 now?
7:30
Okay.
to 5?
7:35 now, so we got 10 minutes.
You got 5.
5 minutes, all right.
You're 50 minutes. What? You're 50 minutes.
50 minutes? Okay. Who's bored? Okay, Joel's bored.
I want to know the answer.
All right, so.
Next talk starts pretty soon.
Okay, so the next thing that we're going to do is we're going to write a solution to this, okay? I'm actually going to write out the code. So the thing that we learned from this is that it uses a fixed value at the beginning, so an OX4, right? And it XORs that against the input data and stores that in a data segment. And then it does the loop again and compares that against the original data, which sounds a lot like a stream cipher, because it takes the intermediate values and compares those, and then you can use those to recover the key that's put in. So that's what's happening in this case. So we'll take these values, copy the board. And we're going to dump them in Vim.
Damn it. He's doing it on purpose. Just oh, that's mad. You paid for that.
You paid for that. All right, so here's the cool thing, is I can just tell it to do this. them all in one line, and replace them all with bytes. So this is meant to simulate our data segment, right? We have these values stored in memory. 0x69 was our last value. You're fired. And we know that we had this intermediate byte of 0x04, right? And we need a place to store our solution. And we need to know, as we saw in the loop, it started off with the end of the value, right, and worked its way back, because it started off with 16 and went back all the way down to 0 before it ended the loop, and then did the next comparison. So we're going to set our x equal to the length of ds, but we also know that it started with a fixed value. So we don't want to do the whole array, but we want to start it with a -1. Okay, right? Agree? No? Sure, why not? Okay. And then we're going to do while x is greater than 0 in Python speak, because we're going from the maximum value all the way down, and so what we need to do is x equals or minus equals 1 to decrement the counter as we're going down. And then we are going to redo the instructions that we saw happening, which is we're going to take the index of ds, x, we're going to XOR that by our intermediate value, and we're going to store it in solution. Okay? Everybody following what's happening there?
Sure.
Yeah. What?
Font size.
Font size. Oh, font size. Yay!
Take away the red.
Okay, can you see what's happening now?
Yay!
Bigger? Okay, so we've set the we've created the initial array of the data that's stored in the data segment, right? We found the initial value that it uses to XOR the data. We created an array to dump our intermediate values into, and we've started at the end of the array -1 because we know that it starts with this fixed value, not with the value in the array. And then as we go through, we are XORing this data, and actually we want to do this. And then we saw that the next intermediate value, was set to the current operation. So if we try to run this, it does nothing, because we have to print it. And it gives us an empty array. Well, x is less than, greater than 0. Probably help. So we end up with these values that it's not really sure what's happening, right? So we are going to instead do a oh yeah, byte. All right. And this is why you don't do the slides.
Drink.
You're good. This is how I normally come with all these people staring at
Does it just end? Is that what it is?
That's what I'm
crap.
asking.
Oh man. All right, let's run the one that I wrote earlier. What do we think?
Wait a minute.
Cooking show.
Pre-baking. Wait a minute.
What's the air?
Post up stack exchange.
Seriously. Oh, I need more alcohol, I think.
Explain your work.
All right, so we just went through and iterated through appended value, the intermediate value. Let's take a look at.
How much do you want?
So it looks pretty damn close to what I wrote before. X and
Solution reverse. Reverse engineering.
yeah, but that's
Enter equals byte. Use a
Yeah,
Mac.
you have inner equals XOR, inner equals byte.
yeah. I just changed the name of the
Okay.
argument.
Sorry.
It should work. All right. Well, we'll run this one. Let's see. Python 3.
Less than 0 on the right.
And it runs your your ultimate value there. Okay? So anyway, remember the answer wasn't really what we were going after here. It was how do we get there, right? We run through, take a look at our call graph, try to figure out what the fuck is going on. Go in, comment our code, take a look at what's happening, find the loops, try to derive what's happening. So after having done all that bullshit work, I'm going to show you that if you just buy the Hopper disassembler and you say, open this thing, Ignite, okay? We're gonna run it, say, yeah, it's Windows code. We have an entry point here, and we hit this button, it literally tells you what the fucking code is. There's your answer.
Wait, what?
Good night.